Descriptive and inferential statistics. Descriptive statistics. 1. Organization of data. Data must be organized systematically for analysis. This is done through classification and frequency distribution. A. Classification of data. Data can be classified into various types based on certain criteria. Frequency distribution. A frequency distribution organizes data into categories or intervals to show how often each value appears. Types of frequency distribution. Relative frequency distribution shows the proportion of each frequency relative to the total number of observations. Relative frequency equals frequency of a class total frequency / text, relative frequency equals / frac, / text, frequency of a class, / text, total frequency. Relative frequency equals total frequency of a class. Cumulative frequency distribution shows the total number of observations that fall below a certain value. Less than cumulative frequency, cumulative sum of frequencies from the lowest class. More than cumulative frequency, cumulative sum of frequencies from the highest class. Cumulative relative frequency distribution combines cumulative frequency with relative frequency. Frequency distribution with grouped and ungrouped data. Ungrouped data, raw data without intervals, e.g., test scores 45, 50, 55, 60, 65. Grouped data, data divided into class intervals, e.g., 40 to 49, 50 to 59, 60 to 69. Construction of frequency distribution. To construct a frequency distribution, follow these steps. Determine the range equals maximum value, minimum value. Decide the number of class intervals, typically between 5 to 20 intervals, depending on the data size. Set the limits of each class interval. Define lower and upper class limits for each interval. Methods of class interval construction. Exclusive method. The upper limit of one class is the lower limit of the next, e.g., 10 to 20, 20 to 30. Inclusive method. The upper limit of one class is included in the class, e.g., 10 to 19, 20 to 29. True or actual class method uses actual limits considering decimal values. 2. Graphical representation of data. Graphs provide a visual summary of data. Histogram, a bar graph showing frequency distribution. Frequency polygon, a line graph showing frequencies of class intervals. Frequency curve, a smooth curve drawn over the frequency polygon. Cumulative frequency curve, ogive, a curve showing cumulative frequencies. 3. Diagrammatic representation of data. Diagrams are useful for comparing data visually. Bar diagram uses rectangular bars to represent data. Subdivided bar diagram, a stacked bar chart dividing categories within bars. Multiple bar diagram displays multiple sets of bars for comparison. Pie diagram, a circular chart divided into sectors. Pictogram uses symbols or images to represent data. 4. Tabulation. Tabulation is the process of systematically arranging data into rows and columns for better clarity and analysis. It helps in organizing raw data efficiently, making it easier to interpret patterns and relationships. Tables can be simple, double, or complex, depending on the nature of data. Proper tabulation enhances readability and supports decision-making in research and statistics. Inferential statistics. Inferential statistics involves making predictions, inferences, or generalizations about a population based on a sample. It includes estimation and hypothesis testing to draw conclusions beyond the available data. 1. Estimation. Estimation is the process of determining an unknown population parameter using a sample statistic. A. Point estimation. A point estimate provides a single value as an estimate of a population parameter. B. Interval estimation. An interval estimate provides a range of values within which the population parameter is likely to fall, along with a confidence level. 2. Hypothesis testing. Hypothesis testing is a statistical method used to decide whether to accept or reject a claim about a population parameter. A. Level of significance, alpha/alpha. The probability of rejecting a true null hypothesis. Common values, 1%, 0.01, 5%, 0.05, 10%, 0.10. B. One-tailed and two-tailed tests. One-tailed test tests for an effect in one direction only. Two-tailed test tests for effects in both directions. C. Errors in hypothesis testing. Type 1 error, false positive. Rejecting a true null hypothesis. Type 2 error, false negative. Failing to reject a false null hypothesis. D. Power of a test. 1. The probability of correctly rejecting a false. 2. A higher power indicates a more reliable test. Procedure for testing a hypothesis. Step 1. Set up a null hypothesis suitable to the problem. Step 2. Define the alternative hypothesis. Step 3. Calculate the suitable test statistically. Step 4. Define the degrees of freedom for the test situation. Step 5. Find the probability level P corresponding to the calculated value of the test statistics and its degree of freedom. Step 6. Reject or accept the null hypothesis on the basis of tabulated value and calculated value at practical probability level.
Thank you so much for watching. Don't forget to like, share and subscribe. See you in next video.